So hey guys, in this video I'll be talking about how you get the water flow through each pipe and the resulting net flow through each pipe. So first off, we're going to need the equation for the frictional factor. So this equation, P2 minus P1, so drop in pressure, over rho G, plus gravity, change in elevation or position, and the change in velocity. And I don't remember, pretty sure this is over 2. And it's going to be equal to the negative frictional force. So to make this simpler, we're going to just divide everything by G. So there shouldn't have actually been a G there, but it won't matter. Get rid of U, add U, divide by G. And what we know is we need velocity. So velocity to find the friction force. And we need the head and drop to find the friction force also. So let me draw an image of this. So we'll have 1 pipe here, 2, 3, 4. And there's different flows going in and out. And this is this is where all the flow rates are coming in and they're getting directed to each separate pipe. And this one is going out. So from what this is, you know, velocity is going to be negative and positive depending on which way it goes. And what we have up here, this little section is going to be the drop in head. So that right there is D head. But what we need is to get the frictional force actually and substitute that in for a different equation. So insert a blank page. So the friction force, so negative F is equal to the sum of K plus 4 F L, say change, let's keep it L over D. And we gotta multiply this by velocity squared over 2. And I believe there's a multiplication of velocity squared over 2 here as well. So there's 2 of them, one right there, one right there. So when you factor this out, this is just over F. We're gonna include the G later. So let's just get the sums. We'll just get K plus 4F over D over V2 squared. It's equal to that. And then when we put that into the equation, we bring it up to the other side and we divide it by G. So what we had here before is P2 minus P1 over rho G plus Z2 minus Z1 plus, since it was negative and we're bringing it over here, B squared over 2 K plus 4F over D. And this F here is going to depend on Reynolds number and velocity. And we know the Reynolds number, so Reynolds number is equal to rho V D over U. And the velocity, I believe, is equal to 4Q pi over D squared. I'll actually check that to see if it's right. Let me get that stuff off the screen. I was trying to change my own view, but what I found out is it's, let's go to draw. It's not, well, it doesn't matter. It's 4Q over pi D squared. And let me not forget the G there, since you're dividing everything by G. As we said, this part here is D head. And this F is going to be important because a good guess for F is needed to find the flow rate. And the flow rate is related to V, which is why we're going to need Reynolds number and velocity to solve this equation. So now that we have the basics set up, we can actually start the coding. So let's do that. Start the coding. And these are just going to be some equations that we're going to need later on. And so as we start the coding, we're going to need to find the Reynolds number. So we'll make a function that defines that. So define RE. So that'll be our Reynolds number in ED. Control Z that. And make sure I add the colon because that's what I always forget. And I'm actually going to copy and paste a function. And I'll explain what it is afterward. So let me indent this. And this is actually the recurring fan friction function. So some of these values are set values that are already in place that I took from an online equation. And this will actually help us find the Reynolds number for any given values of relative roughness, the ED, and it'll return a friction factor. So we do that, and it says invalid syntax. And why does it say that? Because I didn't define what it was, actually. I still didn't. So I actually just say what that is. Let's say L for now. Expected indentation. Yep. Let's just say F of 101. So run everything. Shift enter, shift enter. Yeah, because I want this to be F. So, man, that seems about right. So once we got that, now we need to find the D head value. But to find D head, you're going to need some variables. So let's say define D head. We're going to need now a length, a diameter, a relative roughness. And what else? You're going to need Reynolds number. And there's one more variable I'm forgetting. So ED. I don't think you'll need that. You need a K and you need a flow. So put that. And I didn't want to shift enter. Yeah, that's not going to work. I want to put in it. So we're going to need a velocity. It's going to equal to Q divided by P dot pi. So we put that across P dot pi times D divided by 4. And what we're going to need is a row value. That row, it's not a row value. You're going to need a row value in it. We're trying to find Reynolds number. So Reynolds number equals row times G times V divided by mu. So we're going to actually have to define some functions. So I'm going to move my video a little bit. And let's move it back. So we're going to need to define row. So row is equal to 1e to the third mu, so that's equal to 1e to the negative 3. And we have gravity, which is equal to 9.81. So as we do that, and what we want to return is, let's get negative K, because it's going to be negative, plus 4, instead of F, RE, so Reynolds number, relative roughness, multiplied by L, divided by D. So I have this all in parentheses, let's see that, yep. And you're going to multiply this by the velocity squared, and divide it by 2G, doesn't matter if it's on the inside or outside. This needs to be squared as well. Shift enter, and same we have invalid. So let's run it from the top. And it's still saying invalid, so let's see. Array equals. And use a function. D is a function. Invalid syntax. This means the line above. I'm missing a parenthesis. Yep. And here's probably the same exact issue. Okay. Plus 4. Times 2 divided by G. So, yep, and let's check this. So D head of L. So 10, 5, 5, 1e to the negative 3, 1.0, we'll make you 1.5, and shift enter. It's not callable. Let's see if there's anything wrong. Don't see anything wrong here. Alright. So it should just give me the number, but it's saying there's something wrong up here. Oh, it's a number. Yeah. Got V, so that's the same variable there. K. Should be negative, yeah. G. G's defined as a variable. I think I found. Yeah, it's supposed to be times 4 F. That's what it's supposed to be. Actually, this negative should be outside. Yeah, it gives me a very, very small number. Let me try this with see if I get it right with a number I know. 0.1. Yeah, it gives me a number that I'm almost for sure is the right number. So now that we have D head, we need to find the flow next. So let's do a function that defines flow. And we're going to do some of the same values. Okay. L, relative roughness, D head, and I believe that is it actually. So now that we have that, we want to use this function to return actually a resulting flow. Let's say underscore rate. But we don't know what to add in between. We need to actually find the initial zeros from each pipe where it's going from in, out to in. So as we do that, shift enter, it should give us nothing. We define, let's say, a flow, so an F to 0 function. In doing this, what are we going to need here? Is I believe we're going to need most of the same stuff, so still a K, an L, an ED. To be honest, I think we're going to need the same as the define head function. And a Q. I believe actually we can use the same stuff here as we had before. So let's Control V. So this time we're going to have to change that to little v, because it's not the exact same velocity. And I believe you're going to return actually the same exact number. Except this time, instead of just the right side, it's like what we had before. You're adding delta head. So it's delta head plus or minus. I'm going to stick with minus still. And this is all I have for this video, but I'll continue in the next video.